Welcome to a brand new unit on linear functions. And just as a quick little heads up, when we say linear functions, what we're really saying is a straight line. It's really a straight line graph. And we're going to go through a little bit more about what that is as we go through this unit, as we kind of dive into what are linear functions and what do they represent. Now, a linear function compares two different variables or two different things. And there's a ton of things that we can compare. We can compare cost to weight, we can compare distance to time, we can compare speed, all these things, or words typed per minute, which is a little bit something you'll see next year when we start talking about rates. But we can compare all sorts of different things, and when we compare those two things, there are times that we can compare them as a linear function. And so we're going to look at how do we look at linear functions and what do they represent. When we draw them out, we can draw them out on a graph, okay, in a straight line, or they can be written into a formula which will be used to extrapolate, and that's a nice big word, data that's outside the drawing graph. So a linear function is a straight line graph which represents the comparison between two different variables or two different things. Okay? One of them is going to be kind of usually dependent on the other, but whatever it is, they'll be that's what a linear function is. We can graph it out, and we're going to take a look at an example of a linear function shortly, or they can be written into a formula which will then be used to, or can then be used to extrapolate data. And when we say extrapolate, this is find, more or less mean to find out. Okay, so we're going to find out data that is outside of the graph or is outside the line, or really any point. Okay, so we can graph out something, and we'll take a look at another number of examples, and we'll talk about extrapolating and how what that does as we go through. So I'd like to give you or take a look at an example, and this example is really difficult to do without the class in front of me, but I'm going to use an example from a previous class as to what it looks like. So if we were in class, I would be doing this example with all of you. We would be using measuring tapes, and we would be determining how tall each of us was, as well as what our arm span is. And now the arm span is just how far it is from the tips of your fingers, okay, when you stretch out your arms to make kind of a T, or if you want to think of it as a cross. Okay, if you stretch out your arms like a cross, the distance between the tips of your fingers is your arm span. And there is usually or often a relationship between the height that you are, height, to arm span. And if I had a little model of a person here, I would show you, but I don't, so I apologize for that. But if we graph it out, it will come up with something that looks like a linear function. So I want to show you an example that I did with a previous class. It's one I've printed off from my notes that I'm glad I've kept now. And so what we did as a class, and this was maybe last year, maybe the year before, I can't remember exactly when, but we found the height and arm span of everybody in the class. And so in this class, you can tell there was a number of students. Everybody wrote it down. If you want to dissect the writing and figure out exactly whose it is, you can do that. Oh, it might be kind of impossible, but that's up to you to decide. And then what we did is we took that and we graphed the data. Okay, so we kind of forgot to put in a title here, but this is height versus arm span. Okay, so height versus arm span. The heights we did from 130 to 200 centimeters, we wrote there. The arm span we did from, again, 130 to 200, and then we graphed out all the points. Okay, so we didn't start at 0, we started somewhere different, which is okay. We graphed out all the points, and this is where the points ended up. So you'll notice all the different points that ended up on this graph here, and there's a lot of them. Okay, every single one of these led to one of these points. So in other words, every single one of these points had some sort of description that goes along with it. Now you'll notice that these points aren't in a straight line, but they kind of form a bit of a straight line in they go from small to big. They kind of follow this straight line, which is why I drew what I would call a line of best fit through there. Even though they're not all on the same line, there's kind of a general pattern that is forming. And we'll notice that based on this line, that the shorter you are, the shorter your arm span would be. The taller you are, the farther or the longer your arm span would be. And so it's a direct comparison, or a fairly similar comparison to that. Now we could also do this with different programs, and maybe at some point I will show you how we can compare it with a program. But for right now, this is what we call a line of best fit. Okay. Now, this is just a way of doing a comparison. If we could determine what the function was for this line, we could then try to extrapolate or determine someone who was taller, what would their arm span likely be? Someone who's shorter, what would their arm span likely be? And we can start to see the relationship that is forming between the two.